So, expectation of variance for the geometric distribution. Reminder what the geometric distribution is. It's you're trying something for an unknown number of times. You're trying something repeatedly until you get your first success, and then you stop. So the formula we had for working that out was failing lots of times, that probability, and times by the final success. So if we're looking for the probability our first success will be on our rth attempt, we will have r minus 1 failures with a probability 1 minus p, and then we'll have our 1 success with the probability p. Now consider the example of rolling a fair die until you get a 5. Well, in that case the probability of success will be 1/6. Now just think, how many rolls on average would you expect to have to take until you got your first 5? You're probably thinking you'd expect it to occur on average once every 6 rolls, and that's correct. I think, well, where does this 6 come from? It's linked in with the p-value here, and it's 1 divided by 1/6. Because if I did 1 divided by 1/6, I would get the 6 value here. So the mean is 1 divided by p, 1 over p. You don't need to be aware of the proof of that. I hope it sort of seems a bit logical. If you want to look in the proof, it is in your textbook. You will not be asked at all about the variance of the geometric distribution. It doesn't actually have one, it doesn't exist. So you don't need to worry about the variance of the geometric distribution. So, before we just finish, a summary of everything we come across in this chapter. For a general probability distribution, that isn't a special one like the binomial or the geometric, to get the expected value, you times each probability by the value associated with it and you add them up. We call that the expected value of x. The mean, we may use the symbol mu. For the variance, we work out the expected value of x squared, and that formula is adding up each probability times by the square of the value it's associated with. And then we take away the expected value of x squared. If we're using the binomial distribution, the expected value, the mean is just np, and the variance is np1 minus p, or npq if you use that notation. For the geometric distribution, the mean, the expected value, is 1 over p. And that concludes this chapter 8.